In this video, we are again going to talk about sketching the graph of a polynomial, only this time our polynomial is not given in factored form. Now we still want to know the zeros of our polynomial. We still want to know what numbers can you plug in for x that will give you an output of 0, but it's not so obvious, okay, if it's not in factored form. So what we're going to have to do here is factor it. Now normally it's kind of difficult to factor a polynomial that's like a degree 3 or degree 4 or higher, but notice in this case it's actually not going to be too bad because each of these terms have an x. Okay, so we can pull out the x, right? There's no constant term here. In fact, each of the terms have at least an x squared. So we can write this as x squared times something. Okay, now x squared times what would give you x to the fourth? Well, x squared times x squared would give you x to the fourth. And then we're going to have minus a 2x, right? Because x squared times 2x is 2x cubed. And finally, minus 15. Because x squared times minus 15 is minus 15x squared. Okay, so we just pulled out the x squared from each of the terms. Now, what's inside the parentheses here, we should be able to factor this. I think I rigged it up so we could factor it nicely. We'll put an x here and an x here. Notice if we do x minus 5 and x plus 3, if we multiply those out, we get this, right? We have a minus 5x and a plus 3x gives you minus 2x. And minus 5 times plus 3 is minus 15. So now it's much easier to see what the zeros are of this polynomial. What numbers can you plug in that will give you an output of 0? Well, one of them is minus 3. Okay, if we plug in minus 3 here for x, we're going to get positive 9, right? If we plugged in minus 3 here, we would get minus 8. But if we plugged in minus 3 here, we get 0. So what's 9 times negative 8 times 0? Well, of course it's 0, because whenever you're multiplying by 0, you get 0. Okay, so minus 3 is a 0. Also, because of this factor, 5 is a 0. Okay, and it's positive 5, because if you put in 5 there, minus 5, you get 0. So you'd have 25 times 0 times 8. Of course, that's 0. Now we have one more. Because of this x squared term out here, 0 will be a 0. If you have an x or an x squared or an x cubed or an x to the fourth, as long as it's just x and you don't have a plus something or minus something, 0 will be a 0. Now it sounds kind of weird to say 0 is a 0, but that's exactly the case. Not only are minus 3 and 5 zeros, 0 itself is a 0. In fact, if you plugged in 0, notice this whole thing would all multiply to get 0 because you'd have 0 times negative 5 times 3. Okay, so we found our zeros for this polynomial. And so what we can do now is plot those zeros. Okay, minus 3, 5, and 0 itself. And those are going to be the x-intercepts of our graph. Okay, the places where our graph touches the x-axis. Now the question is, what does the rest of the graph look like? Okay, well I like to always maybe pick two of these points and pick a number between the 2 points. So in between 0 and 5, let's say, let's plug in a number that's between 0 and 5. So I don't know, let's plug in 1. So what would f of 1 be? Now you could either plug in 1 in for x in this top expression here, or you could plug in for x here. I like to plug it in when it's factored, right? If we plug in 1, we get 1 squared, which is 1, times now 1 minus 5, that would be negative 4. Plug in 1 here, you get positive 4. Okay, now 1 times negative 4 times positive 4 is negative 16. So that means since we plugged in 1, we got an output of negative 16. The point 1 comma negative 16, which is way down here, is going to be on the graph, 1 comma negative 16. Now what if I had plugged in 2 or 3 or 2.9 or 4.1? If I plugged in any number between 0 and 5, we're definitely still going to be below the x-axis. How do we know that? Well, this is a continuous function. It doesn't have any jumps in the function, and we can't cross the x-axis because we already found all the zeros. These were the only zeros, these three numbers, so we can never jump above, so we're going to be below the x-axis. So let's just sketch in the graph here. Okay, and again, we're just doing a rough sketch. This graph is not perfect. Okay, and now let's plug in something that's between minus 3 and 0. So let's plug in minus 1 this time. Well, if we plugged in minus 1, well, minus 1 squared is positive 1. Minus 1 times minus 5 is minus 6. Minus 1 plus 3 is 2, so what we get is negative 12. So notice minus 1 comma negative 12, that'll be on the graph. So notice we're not above the x-axis here, we're actually below the x-axis again. Our graph is going to look something like this. Okay, it dips below the x-axis at 0. It sort of bounces off the x-axis. Now let's remember here, this is, let me write this again here, this is minus 3, this is 0, and this is 5. Okay, now what about if we pick a number bigger than 5? Is it going to go up here, or is it going to bounce off at 5 again? Well, let's try. Pick a number that's bigger than 5, so let's pick, let's say 6. Okay, what's f of 6? Well, if we plug in 6 everywhere we see an x, we get 36, right? 6 squared. And then 6 minus 5 would just be 1. And then 6 plus 3 is 9. Now 36 times 9, that's a very big number. It's over 300. In fact, I think it's 324, I believe. The point is, it's a positive number. It's actually a very big positive number. So if we went over here to 6, this would be up at the way up here at 6 comma 324. And the point is, it's a positive number. If it were negative, it would be way down here. But it's positive, so our graph is going to look like this. And finally, if we picked a number that's less than negative 3, let's try f of negative 4. Well, we plug in negative 4 everywhere we see an x, we get positive 16, right? Negative 4 squared is positive 16. Negative 4 minus 5 would be negative 9. And negative 4 times, or plus 3 would be negative 1. And actually notice the point is it's all going to be a positive number. Now 9 times 16 I believe is 144. And then we get positive 144 because these negatives really cancel each other out. So at minus 4 comma 144, that's way up here. The point is it's positive 144, not negative 144 down here. So the basic shape of our graph looks like this. Okay, this is a basic rough sketch of our graph. So what did we have to do here? Well, the first thing we did was we factored our polynomial, and the reason we did that was because we wanted to find the zeros of the polynomial. Okay, and to get a rough idea of what the graph looks like, once we have the zeros, we just need to find in between these zeros, is the graph above or below the x-axis? So between 0 and 5, is the graph going to be up here, or is it going to be down here? It can't be both because we're not going to cross the x-axis anywhere between 0 and 5. So we found it was actually below, and the way we found that was we picked a test point. We picked the number 1. Okay, just pick any number between 0 and 5. I picked 1. And we plugged in f of 1, we get minus 16. So you're at the point 1 comma minus 16. Now again, if you tried to do this on your graphing calculator, it probably wouldn't show up very well unless you had the correct viewing window. Your x's, you can maybe go from maybe like minus 10 to 10, but along the y-axis, you might need to go from like minus 300 to positive 300 or something maybe even bigger than that. So it would look a little bit distorted if you try to graph this on a graphing calculator.